So hello, this is the continuation of the video number 1 because it is being cut. So again, to obtain geometric sequence, to obtain R or the common ratio of a given sequence is to divide any term by the preceding term. So this time take a look, 8 divided by 4, that is equal to 2. Next is 16 divided by the preceding number, which is 8, that is also equal to 2. For the third one, we're going to get again the quotient as 36. 32 divided by the preceding number of 32, which is 16. The result or the quotient will be 2. Next, we have 64 divided by the preceding number or the preceding term, which is 32. That is also equal to 2. 128 divided by the preceding number, which is 64, is also equal to 2. And lastly, 256 divided by the preceding term, which is 128, that is equal to 2. So this means that our common ratio sa atong given sequence, which is the number of eggs, is equal to 2. This is our common ratio or our R. Now, recall with the discussion we have about arithmetic sequence. Arithmetic sequence is a sequence in which each term after the first term can be obtained by adding the preceding term by the fixed constant called the common difference. So ma-obtain daw nato ang ikaduha, makakuha ta sa ikaduha nga term by adding a constant sa atong first term, and that constant is what we call the common difference. For example, we have 5, 10, 15, and 20. So we can get the common difference by subtracting the term by the preceding term. So we have unsay preceding term sa 10. We have 5. So we have D denotes as the common difference. D minus the preceding term is equal to 5. That is equal to 5. Next, 15 minus the preceding term, which is 10. That is also equal to 5. Lastly, 20 minus the preceding term, which is 15. That is equal to 5. So therefore, the common difference of this arithmetic sequence is equal to 5. Now, in geometric sequence, you will find a common ratio, while in arithmetic sequence, you need to determine the common difference. So, meaning, when we talk about geometric sequence, ang naa is ang common ratio. You need to get the common ratio or R. And for the arithmetic sequence, we need to get the common difference, also denotes as D. Okay, so to understand further about illustrating geometric sequence, let us try to solve some example problem. So example for geometric sequence. A is solving for the common ratio. So we have here a table, 3 examples shown in the table. So the first geometric sequence are 4, -8, 4, -8, 16, and -32. How are we going to find the common ratio since it is in geometric sequence? So how are we going to get the common ratio? Unsaon ganito? How is to divide the term by the preceding term. So we have 8 or -8 divided by 4, ang preceding sa -8 is 4. So divided by 4, that is equal to -2. Next, we have 16 divided by the preceding term, which is -8. That is also equal to -2. And lastly, the fourth term, which is -32 divided by the preceding term, which is 16. The quotient of that will be equal to -2. So therefore, the common ratio of a geometric sequence for -8, 16, and -32 is equal to -2. Okay? So for example, number 2, we have sequence or geometric sequence written as 81, 27, 9, 3, and 1. We're going to get the common ratio. So again, in order to get the common ratio, we're going to divide the term by the preceding term. So kuhaon na to ang iyang quotient. So we have 27 divided by the preceding term, which is 81. And 27 divided by 81 is equal to 1/3 or 0.33. Okay. Next, the same process. 9 divided by the preceding term. Ang preceding term na sa 9 is 27 na. That is equal to 1/3 also, or 0.33. Next, we have 3 divided by the preceding. Ang preceding sa 3 is 9. That is also equal to 1/3. And lastly, 1 divided by its preceding term, which is 3. That is equal to 1/3. So therefore, the common ratio of this geometric sequence is equal to 1/3. Okay? So for our last example, we have still a geometric sequence, -3, 9, -27, 81, -248. So the same, the unknown will be the common ratio. So kuhaon ang common ratio. So the same process, in order to get the common ratio, divide the term by its preceding term. Term divide sa iyang gisundan nga term. So we have 9 divided by -3. That is equal to -3. Next, -27 divided by 9 also equal to 3. 81 divided by negative 27 also equal to 3, and negative 248 divided by 81, that is equal to 3. So therefore the common ratio is also equal to negative 3. Okay, let's have next example for our module number 4. So illustrate geometric sequence given the first term and the common ratio. Now this time we're going to get the first 5 terms. Ang first 5 terms atong geometric sequence, which are only given are the first term and the common ratio. So the first term is equal to 2. Okay? So to obtain the second term or the a sub 2, we're going to multiply the first term or the preceding term to the common ratio. So since naman tay common ratio, ang preceding term sa atong second term is 2. We have 2 times 2, that is equal to 4. Next, our a sub 3 or the third term is equal to, so may preceding term na niya, 4, multiplied by 2 as its common ratio, is equal to 4, or 8 rather. The fourth term is equal to 8 times 2, common ratio, so 16. And lastly, the fifth term is equal to the preceding term, which is 16, multiplied by the common ratio, which is 2, that will be equal to 32. So therefore, the first 5 terms of a geometric sequence are 2, 4, 8, 16, and 32. Okay, so we have number 2 example. The only given again are the first term and the common ratio. Now we have the first term that is equal to negative 1, and the common ratio is equal to 3. So we have a sub 1 that is equal to negative 1. A sub 2, to obtain the a sub 2, we're going to multiply the preceding term times the common ratio. Ang preceding term niya is negative 1 times the common ratio, that is equal to 3. So our second term is equal to negative 3. A sub 3, preceding term, negative 3 times 3, that is equal to negative 9. A sub 4 or the fourth term is equal to the preceding term, which is negative 9 times the common ratio 3, that is equal to negative 27. And lastly, the fifth term, that is equal to the preceding term, which is negative 27, multiplied by the common ratio, which is 3, that is equal to negative 28. So therefore, the first 5 terms of the geometric sequence are equal to negative 1, negative 3, negative 9, and 27, negative 20 or negative 81. And lastly, for our third example for module number 4, which is illustrating the geometric sequence, given are the first term 3 and the common ratio, which is positive 2. So I have solution. A sub 1 is equal to 3, a sub 2 that is equal to 3 times the common ratio, which is 2, equals to 6. A sub 3 is equal to 6 times the common ratio equals 12. A sub 4 that is equal to, gisundan sa a sub 4 ang 12 times ang common ratio, which is 2, that is equal to 24. And lastly, a sub 5 or the fifth term is equal to the preceding term, which is 24 multiplied by 2, that is equal to 48. And therefore, the first 5 terms of the geometric sequence having the first term is equal to 3 and the common ratio is equal to 2 are 3, 6, 12, 24, and 48. Okay, so that's all for our module number 4, I think, which entitled Illustrating the Geometric Sequence. So I hope you learned something and you can be able to answer those activities given in the module. So stay updated for more lecture video with our discussion. So thank you and good day everyone.